Good morning, everybody. How's it going? Happy Friday. Whoop, whoop. Hooray. All right, welcome to Friday edition of DM2. So today we are going to hop into Grasshopper and hopefully get a little bit more fluent and start doing some more interesting Grasshopper magic stuff. First class was a little bit slow and basic, so this time hopefully we'll start to pick up the pace a little bit and explore some more kind of interesting applications of Grasshopper. This is where we're going today. We're going to explore what's called an attractor point in Grasshopper. So this is like a basic definition that helps you establish basic things like size or scale of objects relative to a point that you can control inside of Rhino. So this is where we're going. It's an algorithmic definition that we'll set up in class today. This is also going to be the subject of your checkpoint. So today's very basic checkpoint is just going to be to follow along with what we're doing in class and upload a screenshot of some sort of attractor point definition by the end of class today. Again, like I mentioned last class, I've shortened or tightened the deadline a little bit. It's not to punish you. It's just to make sure that you don't spend too much time on this stuff. We really just want you to get in, get out. And I know there's keeners in the class, so you have to be a keener to make it in this program. So I think we'll just try to tighten the window a little bit to 1:30. I can stick around a little bit after class. We'll try to keep class today pretty brief and pretty short so you can spend some time messing around in the program. But otherwise, that's where we're going today. Before I get started, I also just wanted to share some of the highlights from our first checkpoint because some of them were incredible. So these are some of my favorites. We had a little baby duck with a hat. Cute. Lots of animals, especially birds. A little kitty cat and sardines, so cute. This one was rendered out in Blender, so very cool rendering. An anatomically accurate human heart, which is a little scary. Metallic crab, metal crab. A spoon in a plane? Is this a plane? Or a orca whale? Oh, it's a whale. A spoon whale? Okay, anyway, really cute. Very impressive chair design. Pingu. Very cute. A little turtle, lots of animals. I love the cute vibe. Spooky snake. This one is very morbid, but I love it. Des 212 is in its grip. A little wooden bird, very cute. Lots of animal skills. This one was my favorite, so I'm a little bit biased. We've got a really cool Mothman, a little symmetrical moth, Patrick Star style. Little Miss Miffy, really well rendered, actually. Nice use of materials, so great. A little kind of moody planetary scene. I don't know what this is from. What is this from? Pokemon? Okay, sorry. I'm so ignorant. It looks amazing, really incredible. And then some ramen. So, overall, incredible, super cool use of sub D. Don't work this hard. This is a lot of hard work. Super impressed with the quality of work so far, but I really don't want you to be not focusing on studio or something to do your checkpoints. But anyway, just really incredible animal rendering skills. So those were some highlights from last week. Where we're going today, today we're going to be focusing on building some relationships in Grasshopper that lets us do kind of operations like this one, where we can establish relationships of scale that can be used for applications like facades, so like panelization or cutting holes in something like this, which might be an acoustic wall where these little perforations are allowing sound to pass in behind and then material inside to absorb it. This is a cool kind of hexagonal facade panel that uses a similar relationship. So the closer that it gets to this kind of like invisible line cutting across the facade, the bigger that those hexagons get. And that's kind of cool because it opens the aperture more at like human eye height and then fades it out as it recedes. That's another view at the corners, kind of interesting. This one's really cool. It's kind of using the same foundation or principles. Instead of using scale, it's playing with rotation. So the closer that these bricks get to this quote unquote attractor point at the center, the more that they're rotated to open towards the interior. So that's another really cool application of this kind of relationship. And then this is an example from a landscape. So using those same concepts of attractor points instead to give us the root system of a tree. So expanding those pavers at the base, again, using those attractor points, distorting them slightly to allow for something like planting. Here's the diagram of those pavers in the ground in kind of a 2D fashion. So that's kind of the vibe of where we're going today. We're going to use Grasshopper to achieve it. The point of this definition is to help us kind of start to get into the Grasshopper mindset and start playing around with kind of relational properties. So we're going to start from scratch today. I'll open up a new document. We'll start with a nice blank slate. And the first things first, I highly recommend anytime you're trying to do something in Grasshopper, sketch it out first, and it's going to help you figure out the steps that you might be missing, figure out which components or pieces you might need to plug into your puzzle to make things come together. So first things first, all of those kinds of examples seem to have like an underlying grid of geometry that they're working with. So in our case, it's going to be circles. Oh my God, that's a circle. Jesus. Those are circles. And the size of those circles are relative to their location as it relates to an attractor point. So this X, maybe we can start to think about as our attractor point. So the closer those circles are to the attractor point, maybe the bigger they get. This is horrifying, I'm so sorry. Trackpad skills. And then the further they are away from that point, the smaller that those circles can be. So that's kind of like the underlying premise of what's going on here. Horrifying though that may be. And so what this is doing at a foundational level, what it's really kind of calculating is distance. So it's kind of measuring the distance from that attractor point to all of these circles in our grid. And then using that distance value to inform how wide or big the radius of those circles are. So the shorter the distance, the bigger that radius is going to be. The longer the distance, the shorter that radius is going to be. And we could flip that relationship as well. We could have kind of like the opposite setup with a similar recipe. So we could have a grid of circles around an attractor point where the closer they are to that point, the smaller the circles are. Oh my God. And then the further away they get, the bigger those circles become. So that's kind of like the basic premise of what we're trying to set up. So if we look at this kind of basic foundational recipe, there's a few pieces we need to establish. First things first, we need to set up a point. That's going to be our central attractor point. We need to build kind of a grid of circles. Imagine this is a grid. Oh my goodness. So we'll set up a grid. Then we'll start to measure the distance from those grids to that attractor point. These sketches are so horrifying, I'm so sorry. But the gist is basically this. So we'll break it down piece by piece. First things first, we need to get that attractor point. There's a million ways to make a point inside of Grasshopper, but sometimes it's just easier to do stuff straight from Rhino. So to start our definition, I'm actually going to begin inside of Rhino. So I'm just looking in kind of like a general top-down view inside of Rhino space. And to get started, I'm going to place a point. This is going to be our attractor point. So I'm going to grab the point tool on the left-hand side and click to place it on my canvas. This is something I can move around. It's just a normal Rhino point. And we're going to bring it into Grasshopper. I don't think we got a chance to touch on this last class, but you can always reference geometry from Rhino inside of Grasshopper. So to bring this point into Grasshopper, we have to use one of these little container components that's under our first params tab. So we can come up to the tab at the top, params. It should be the very first one. And then it's actually our very first component in the whole shebang is a little point container. This is just like a box or a holding cell for geometry that we want to bring in from Rhino. So I'll click and drag this container onto my canvas. I should have a little component that says point now. It's empty, so it's orange. It's hungry. If you hover over it, it's saying floating point parameter failed to collect data. So it's missing information. It doesn't know what you're talking about yet. You have to tell it. So in order to link something from Rhino into Grasshopper, we just have to right click on that component. So you're gonna right click on point and then come down to set one point. It should be kind of like more than halfway through that menu here. So right click and then choose the option that says set one point. Your Grasshopper window is probably going to disappear if you have nothing selected. So I'll do that one more time. Right click, set one point. Grasshopper is going to disappear and it'll prompt you to select that point inside of Rhino. So right now you can see in the command line it's saying point object to reference. It's asking you for a point. So you can just click and drag a little window over it or select that point, and now it's linked into Grasshopper. Alternately, if you have that point already selected in Rhino, so if you had it clicked on beforehand and then you go to set it in Grasshopper, it knows what you're talking about. It's like, oh, okay, the point you want, it's probably the one that you're holding onto right now. So same process, just right click, set one point. You can tell it's linked into Grasshopper because when you click on that little component in Grasshopper, suddenly that point kind of turns green. We can't really zoom into it too much, just the way that the display settings are in Rhino, but you can see there's like a little baby X that should be green when you click on it in Grasshopper. That's how you know that it's linked. And when you click and drag that point around inside of Rhino, it'll automatically kind of like update that respective Grasshopper point. Okay, so far so good. Pretty straightforward. So next step in our process. Okay, step number 1, get the attractor point. Check, we killed it. Done. Next step, we need to establish kind of all of these circles. Again, there's a million ways to draw a grid of circles in Grasshopper. We could kind of scatter them randomly if we wanted to, but in order to match the kind of the vibe of these kind of images, these all kind of work with a pretty rigorous grid of points at the end of the day. Like they're on a pretty regular grid underneath. Like if I draw on top of this, you can see that there is a line of hexagons here, and then a line below that. Everything's kind of set up in this like pretty regular grid situation. So before we can start drawing those circles, we have to tell Grasshopper where we want them. So first things first, we have to set up a grid for them. We got to figure out in space where those circles are going to be. So next step, let's make a grid. Again, plenty of ways to do this in Grasshopper. Most of them are going to live under the vector tab. So vector, and then this little drop down here which says grid. There's 5 different options for types of grids to work with. So there's some cool ones like radial, hexagonal, triangular, which I encourage you to play with. For today, to keep it simple, I'm just going to use a square grid. So they're going to be evenly spaced in both directions. So I'll click on square and place it on my canvas here. You can also just double click and type in grid or square grid, and it's this component here that says square. So this is what we're working with now. We've got a point floating in space, and we've got a grid of points somewhere. So depending on where you're looking in Rhino space, you might not see much of anything at all, depending where your point is. By default, if we hover over plane, so where it says plane, it says base plane for grid. So this is asking where is this grid being drawn. And by default, if we hover over it, you can see it's set to world X, Y. The component's gray, so that means it's automatically running without any additional inputs. So this default world X, Y, that's the same thing as our C-plane. And based on your view settings and where that point is, you might see it in Rhino or you might not. If you get lost, you can use kind of zoom extents or zoom extents or zoom selected. So you can see my point is kind of like way out in space over here. And then my grid is down at my origin, my XY origin point. So I'm gonna wanna make that grid bigger for sure. It's a tiny little baby grid. There's a couple different inputs on the left-hand side. So plane is happy, it's already running. We don't need to fuck with that at all. Size, that's an input I want to play around with. I want to make those grid cells bigger. So this is a good case for using a number slider. You'll remember from last class, you can grab a number slider either under params, input, and then number slider, or just double click on the canvas and type in whatever number you're interested in. So I want the size of those cells to maybe be like 20 units in each direction. So I'll double click and type in 20. And now I have a number slider set to that number. I can plug it straight into size on square. My grid is suddenly huge. Love that. And I can click and drag that number slider around to change those values really quickly. Is that working for everybody? Yeah.
What's that like smallest grid that's at a very large?
Oh, good question. So if your grid is small in size, you might see that it's kind of like next to this other little grid that is also nested kind of just at that XY point. That's just like a display or like an artifact telling you where this plane input is. So that's kind of like a diagram of what plane you're using to draw this grid in. So there's nothing really there. It's not really doing anything. It's just kind of a diagram for what plane you're using as your input.
Mine's not changing size when I'm using number slider.
Yeah, so we just have to make sure that the number slider is plugged into size on square. Any other questions? Is that working for everybody? Cool. Okay, so we can change the size of those really quickly. We can also use a really similar process for changing how many grid cells we have in each direction. So right now, if you hover over extent X and extent Y, you can see in that little yellow window that pops up that that number is automatically set to the number 5. So for both extent X and extent Y, the number 5 is already kind of inherently set up in there. But that's something we can control with a number slider as well. So I'll do the exact same thing. Maybe I want to have 50 cells in both directions. So I can double click on the canvas anywhere and type in 50, 50, and hit enter. So again, just double click and type in a number of your choice. We'll take that number slider and we'll plug it into both of these inputs here. So extent X and extent Y. We're going to plug that number slider into both of them. You can see when I plug it into extent X, now it's kind of like percolating. Now there's 50 cells going in the X direction. And when I plug it into extent Y, now we've got 50 in the Y direction as well. So we've got a grid of points. I can control the size of that grid, and I can control how big or how far it's kind of going in each direction with 2 number sliders. You could use 2 number sliders if you wanted them to have kind of separate extents in different directions. So if I wanted it really tall, I can make a copy of that number slider and plug it in there, or vice versa. But for now, I'm just going to leave it with 1 number slider plugged into both extent X and extent Y, so we have a nice kind of square grid. Okay, and we can take a look at what's coming out the other side inside of Grasshopper. There's 2 outputs. The one up at the top says cells. And if you hover over it, there's like a little yellow box. Up at the top, it gives you a definition. So it says right now, grid cell outlines. What that means is the box itself, so the little square of each grid cell. We're not super interested in that. We're trying to draw circles here. We don't really need the square shape of the grid necessarily. We just need kind of the points that make up that grid. So that's where this second output, points, is super helpful. I'm going to grab another container component so that we can kind of select and see exactly what's coming out of this points output. So I'll come back up to params up at the top here and grab another point container. So again, that's the same one we used for our attractor point. So params point. And I'll click and place that on the canvas again. You can also double click and type in point. It's going to be this black hexagon with an X in it. We'll plug points into point. And this is just a way so that we can see exactly what we've got. When I click on my little point container component, you can see all of these little corner points turn green. And we can see exactly where all of those corner points are. This is great. This is exactly what we need. In my horrifying little sketch up here, what we've got now is kind of like the backbone of the grid I'm going to use to draw all of my circles. So at each one of these kind of like intersection points on my grid, I've got a little point in green here that we can use to start locating those circles on a regular grid. So that's what we've done so far. We've got our points. Let's start drawing some circles. Any guesses how we can draw circles on these points? incredible. You're a wizard. If you ever aren't sure if something exists in Grasshopper, just double click and search for it. So if you want to draw a circle, I'm just going to double click and type in circle. There's a couple different options, so we're just going to want to make sure we choose the right one. The first option that comes up here for me is a little black hexagon. The little black hexagon is a symbol that it's just an empty container. There's nothing going on in this component. It's not going to make anything for you. It's just kind of like a holding cell for geometry. So if I click this little black hexagon, it's not going to help me. If I plug points into circle, nothing's going on. It's like, those aren't circles, bitch. So not the right circle component for us yet. Instead, we're going to grab the one just above that. The icon is like a little orange square with a circle in it. This component has inputs that sound good to us. It's got plane as an input. So where do you want to draw those circles? And then radius as an input, which is perfect because that's something we want to be able to control. This one is also under curve, primitive, and then circle. So curve, primitive, and then circle. There's a bunch of different ways to make a circle. So if you're not stoked with these inputs, you can play around with all of these other different kind of versions of ways to draw a circle with numbers. But right now, this is kind of perfect for our needs. We just want to be able to control where the circle is and how big it is with its radius. That's all we need. So we've got our points. We have the ability to draw circles. The first input on circle is plane. So you'll remember from our cylinder component, or even just our square grid component, plane is asking, okay, where in space do you want to draw these circles? And what do you know? We have that exact information ready to go from our square grid component. So we can plug this points container holding all of our kind of corner points straight into plane on cylinder. So point goes into plane. Depending what you set the number to early on in your square grid, this could be easy for your computer or it could be very hard. So if your computer is ancient or slow, definitely start with smaller numbers for extent X, extent Y. If you crank it up really high, suddenly it's doing a lot of math very quickly, and your computer might not like that very much. So if it's struggling or moving slowly, just crank this number slider for extents way down. Start small. We'll work our way up. Is that working for everyone? We've got a grid of circles. Yeah, they might be showing up really, really small. So if you're not seeing circles, try zooming in really close on those points, and there might be like a little baby circle. So we can plug a number slider into radius to make those circles bigger or smaller. So we'll double click on the canvas and type in a number. In my case, maybe I'll use the number 5. So double click, type in 5. I'm going to plug that into radius. So this number slider is controlling how big those circles are being drawn. And if we slide around that number, you can see we're starting to control how big those circles are. And if we really crank it up, they start to overlap like crazy super quickly. Any other questions? Is it working for everybody?
General question. How is it, is there an easy way of copying stuff like this? Like, alt doesn't really work.
Oh, yeah, for sure. So the question was, how do you copy components in Grasshopper? So one way that's not working for you is clicking and dragging and then pressing Alt. That makes a copy of it. But the classic tried and true Control-C Control V is also just fine. So Control C, Control V will give you the same thing. If you want to use the Alt option, you have to make sure that you're already kind of like dragging that component around. So it has to be kind of like in motion, and then you press Alt, and you can see it makes like a little ghosty outline of it. And when you let go, then it's got a copy for you. I'll delete that extra. We don't need her. Any other questions at this point? So far, so good? Yeah. Oh, so this is a plugin that I've installed for myself. You guys probably won't see this by default. It's fine if you do. It's maybe just a different version of Grasshopper. This is measuring how long it took that component to run. So 7ms means this component ran in 7 milliseconds, which is pretty speedy if you ask me. That's kind of helpful for if you're running really complicated stuff and you're like, oh my God, is this going to crash my computer? You can see if this number starts to go up and up and up, it's like, okay, I need to scale things down. That's a plugin for Grasshopper that we'll talk about a little bit later in this class, but don't worry about it for now. That's a great question though. All right, so we've got our grid of circles. We're able to control how big they are by playing with this number slider radius input, but it's controlling all of them at the same time. If we come up to my scary sketch, we want to be able to control them relative to our attractor point. So we want to measure the distance between that attractor point that I have in Rhino. It should still be there. I can click and drag it around. What we want to do is measure how far each one of those circles is from that attractor point, and then use that distance to control the radius. So again, if it's super close to our attractor point, then maybe it can have a really small radius. If it's really, really far, it'll have a big fatty radius. And the radius value can come directly from that distance measurement that we can take. So how far is it? We can plug that straight into the radius input on our circle. Does anybody have any ideas for what component we could use to measure the distance between these circles and our attractor point? Hell yeah, distance. Well done. You guys are good at this. So we can double click and type in distance. The icon is a little ruler with 2 points on it. That one is also under vector, point, and then distance. Distance is the perfect component in this case. It is super simple. It's asking for a point A, so what point do you want to measure from? And then point B, what point do you want to measure to? In this case, we're measuring from our attractor point, and we're measuring to all of these little points on the grid. So for point A, we can come back to our initial component all the way back at the beginning here. Right now, it's just kind of floating on its own. There's nothing happening to it. This is our attractor point in Rhino. Again, if you're not sure, click on that component. It should turn green and you'll be able to see what it is. I'm going to relabel this just so I don't get confused. I've got a couple point components, so I'm just going to label it so I know what it is. To relabel or rename a component in Grasshopper, this works for any component. We can right click on it. And up at the top here, there's like a little white bar, a little text entry spot. I'm going to type in attractor point so that I know that this one is key. this is what we want to measure from. So this little attractor point component, that's what we want to measure in our distance component. That's going to be point A. So I can plug attractor point straight into point A. Anybody want to guess what we should plug into point B? We can try plugging in circle. And that totally works. Works just fine. You can see what's coming out the other side if I grab a little panel. So again, to get a panel, you can double click and type in panel, or come up to params, input, and then grab the little yellow square. I'll plug the output of my distance component into panel. And you can see it's giving us a big list of numbers. That's perfect. These numbers are measuring the distance between point A, our attractor point, and point B, all of those points in our grid. This is a big fat list of those distances. Another way to see what's happening, so we can kind of visualize what's going on here, we can also draw a line between point A and point B to kind of show us what exactly is being measured. So I'll grab a line component. So I'll double click and type in line. This is another case where you don't want to get tricked by the black hexagon version. So black hexagon is just an empty container. If I click on it, there's nothing to do. So don't be fooled by the empty one. I'm going to grab the one just above that. The icon is a line with one point on either end. This one's under curve, primitive, and then line. This one's great. It has pretty much the exact same inputs as distance. So start point and end point, pretty much the same thing as point A and point B. So I can plug my attractor point in as the start point. So I'll come back to attractor point, plug that one into start point. And then for the end point, so what are we measuring to? What's that point B? That's going to be our circles. So I can plug circle into end point. And now what you can see is this line component is drawing a line between our attractor point and all of the center points on those circles. If I make my grid a little bit smaller, you can kind of see what's going on with a little more fidelity here. I'm working with fewer points. When I move that attractor point around, the distance to each circle changes. This line is kind of visualizing that distance. So we don't totally need this line component. It's just showing us what's happening here. Is that working for everyone? Yeah.
Can we, instead of plugging to circle, can we plug it straight to the grid points?
Yeah, absolutely. So great question. We plugged circle right into point B. That's one way of doing it. You can also come back a little bit earlier in your definition and just grab those points. So you don't have to use the circle. In fact, it's probably a little bit better if we don't use the circle because we're going to want to come back and change that radius input later on. And we can't really loop the distance back into radius without kind of changing it a little bit. So a good strategy is to come back a little bit earlier in our definition, and instead of using the circles that we've drawn, we can use the points that are at the center of those circles. So we can plug point into point B instead. You can just replace it automatically by clicking and dragging point into point B. It's going to boot out our circle. And you should get the same or similar results. So we're measuring the distance to each point on the grid. I'm going to delete this line component. We don't really need it. It's just good to see what's happening. Now that we've got the distance, we've got a whole list of numbers. And a list of numbers is an amazing thing to have when you want to control an input like the radius. So we've got those distances. Now we can take those numbers and plug them into the radius of our circle. So I'm going to come back to my circle component. I'll delete my number slider. I don't really need her anymore. And now for the input of radius, I can use the output of distance. So distance is going to get plugged into radius on circle. So distance goes into radius. And you can see what we get is a little kooky crazy depending on the size of your grid, but it's probably going to look something like this. And that's because these numbers are pretty big. So if we take a look at these distance numbers, most of them are like 10, 11, 12 for me. They might be totally different for you, but that's fine. So that means that the radius of these circles is significantly bigger than the size of the grid cells we have going on here. Is that working for everybody? Any questions? Okay, so in order to get those circles or those radiuses down to kind of like a more reasonable size, these numbers are too big. We can do some simple math. I'm sorry to make you do math. We're going to come up to the scary maths tab. I promise we'll try to stay out of here as much as possible. But we'll come up to maths, operators, and then we'll just do division. So we're going to take all these distance numbers and just divide them into smaller pieces. So operators, division. It's got two inputs. For A, I'm just going to plug in all of these distance numbers. So I'm going to plug distance into A. I'll grab a number slider and plug it into B so that we can start dividing these values into smaller and smaller chunks. So I'll double click and type in something like maybe 5. So we've got our distance values and we're going to divide them by this number slider here. I'll plug it into B. And if we plug the result into our panel, take a look at what's coming out, you can see the result is much, much smaller numbers. They still have that kind of like proportional relationship, but they're much smaller since we've divided it into smaller pieces. Now we can plug the result of division into our radius input on circle. So we're going to replace what's already in there with the output of division. Division goes into radius. And now we should have much, much smaller, kind of more manageable circles that respond as we move our attractor point around in Rhino space. Yeah, for sure. So we've got the output of distance. These are our numbers that are a little bit too big. We want to make these numbers smaller, so we grab a division component. We plug those distance numbers into division. We'll put them in A. We'll use a number slider to start dividing those numbers into smaller pieces. So double click, grab a number slider, type in whatever number you think is good. I did 5. Plug that slider into B. And then the result of division, we're going to take that and plug that into the radius input on circle. So we can come back earlier in our definition where we had all of our circles being drawn. We've got to find this circle component. And we're going to take the output of division, so the smaller chunks we've divided, and we'll plug those into radius on circle. So division goes into radius. And now when you come back to that division number slider, so division and the slider that's plugged into B, when you make that number bigger, you can see that the relative size of the circles gets smaller. And that's because we're dividing it by a bigger number. We're breaking it into smaller pieces. The lower this number, the bigger the circles. The higher this number, the smaller the circles. If your circles are still huge, it's likely just a function of the number that you're dividing by. So if you're dividing by kind of like a big number like 10 and you're seeing that your circles are still looking crazy big like this, then you're just going to want to change the maximum output of your number slider so that you can make that number a little bit bigger. So my number slider here kind of maxes out at 10. Maybe I want to bump that up to 20 or 50. We can double click on that number slider and come to this max input here. This is controlling how far that number slider goes. So again, I just double clicked on the kind of handle for my number slider. I clicked where it says number slider. Here we can bump up the maximum number. Maybe I'll make mine 100. And I'll check yes. Something else we can do with this window open is change the rounding from natural numbers. So these are kind of like integers, like whole numbers. If I change this N button over to R, that takes it from integer numbers over to floating point numbers. So I'm going to press the R here. I'll hit OK. And now you can see there's a bunch of extra decimals added on. This just means we can kind of get a smoother transition when we're moving our number slider around because it's dividing or it's kind of moving at smaller increments. It gives us a little bit more control. Now this number slider goes a lot further. I can make those circles a hell of a lot smaller. Small circles, big number slider, big circles, small number slider. Any questions? Okay, amazing. That's pretty much it for what we're trying to do today. We can take a look at what's coming out, and maybe we don't want to see some of this other underlying stuff. Maybe we don't want to look at the grid anymore. And that's where we can come back and select our components that we don't need to see. So I'm going to grab everything other than circle, so this final circle output. So I've got everything selected except for my last component. I'm going to right click somewhere off in space. I'll right click and choose preview off. So this spooky little blindfold. Right click somewhere off in space and preview off. And then you're just left with the circles that you're drawing. You don't have to see that underlying structure anymore. It's a little easier to control the size of the circles, all that good stuff. This is all parametric, so the recipe's set up. We can play with the inputs. So I can increase the size of my grid, so the spacing of those points, the extent or number in the X and Y direction, so I can crank up the number of cells it's doing. And I can control the location of that attractor point in Rhino. I'm gonna wrap things up soon. So this is all you have to do for your checkpoint. So to get a full 4 points out of 5, you can just screenshot this right now and upload it to Canvas. If you want to keep playing around with other options in the next kind of like hour or so before the submission deadline at 1:30, there's a few alternative definitions up on Canvas if you want to play around. So under, oopsie, wrong class. It's going to be under files. So files, Grasshopper Attractors. There's a little PNG here with just like a screenshot of a bunch of different definitions that really expand on this basic version that we've cooked. This gets into something called remap distance. So instead of doing our kind of basic division, this does a little bit more fancy math to control what those numbers are doing. We're going to skip this for now and talk about it next class, but you're welcome to kind of play around with these different options. For now, I'll just kind of quickly show you that there's some other things we can do with this kind of base of circles. We can start to extrude them upward. So I can use an extrude component, plug circles into base, and then for direction, maybe I want to extrude them up, so I'll use unit Z. I'm just going fast because this isn't necessary, it's just extra. I'll plug unit Z into direction, and then for factor, I can use a number slider, like 20 maybe. If I come into a 3D view, now I've got kind of a extruded grid. This is another place where I can use those distance numbers to kind of parametrically control the height. So this direction factor, the factor on unit Z, I can plug distance into factor. And now the height of those cylinders is controlled by those distance values. So that's somewhere else we can take it. There's a couple different examples in this PNG, but if they're not making sense, really don't worry. We'll touch up on this stuff in our next class. I'm going to wrap it up there. Oh, sorry, we have a question? Oh, yeah. So to get the heights varied, I'm using that same distance output. So that same distance measurement. I'm plugging that into unit Z on our kind of vertical extrusion factor here. So we're extruding it upward. So I used the unit Z component. And then the factor input on that, so how much do you want to extrude it up? I came back to our initial distance output and I plugged distance into factor on unit Z. That unit Z then gets plugged into direction on extrude, and it's going to shoot your circles upward. Again, all still parametric. If I move that attractor point, she's going to update. Okay, any other questions? Yeah. Great question. So this is a situation where we just have to use our like high school math brains, which I've atrophied after like 8 years of arts education. So I feel your pain. But we're going to take these distance values. If you want to instead have them really tall when it's close to your attractor point, then we can have kind of like a 1 over reciprocal relationship. So we'll take 1 and then divide it by our distance values. That's going to flip the number upside down. And so we kind of get the inverse relationship. So there's a couple different ways we can do that. We can use our kind of standard division option. We can also use this modulus. Or sorry, no, that's the wrong one. Jesus. We want 1 over x. 1 over x. That component is under maths. Polynomials. Jesus, that's a triggering word for me. And then 1 over x. We can plug our distance values into value and then use those numbers. So what's coming out of 1 over x, unplug it into radius. Oop. This is an example where the numbers that you're getting here, they're going to have kind of the inverse relationship. So instead of being too big, they're probably going to be way too small. If we look at what's coming out, these are all like very tiny, tiny decimal numbers. So 1 over x gives us really tiny baby numbers. In order to make them useful, we have to multiply them. So instead of dividing them to make them smaller chunks, we're going to multiply these values to make them bigger so that they're useful for our radius. So I'll double click and type in multiply or multiplication. One over x can go into A or B, it doesn't really matter. So 1 over x goes into multiplication. And then we can grab a number slider to multiply those values by. So we'll plug a number slider into B or whatever remaining input there is. Those numbers coming out the other side should be much more usable. And you might have to crank that number slider way up to get a useful number. We can plug that into radius. And now we kind of have the inverse relationship. So our circles are getting wider the closer they are to our attractor point, and smaller the further away they are. And that's just coming from this 1 over x component. So 1 divided by that value, it's just going to flip the relationship. And then multiplying it by a really big number to make that value usable. We can do the same for our extrusion. So I can plug the output of multiplication. So these really kind of, these numbers that we've manipulated to be bigger, I can plug that into factor as well. This one looks chaotic as hell because we're starting to get a little bit messy. This is starting to mess around with data management. And that's something we're going to touch on a little bit next class. So this one looks a little bit shitty for height extrusion, but we'll talk about why that's happening in our next class. For now, I'm going to stick with my original definition. So division value in radius, and then extrusion factor also kind of coming from that division value. Any other questions? Yeah.
The step where you like where you're at multiplication and you're at the number slider, and like for some reason my numbers are still really small.
Yeah, so you just have to kind of crank up the maximum value of that number slider. Sometimes it's faster, instead of kind of double clicking and making this number bigger, sometimes it's faster to just like double click on the canvas and type in a really fat number like 5,000. So I'll double click and type in 5,000, plug that into multiplication. Now my numbers are really, really big. So it's just a matter of making sure that number slider is a big enough value. It's totally relative depending on the size of your grid and all of those other numbers. But multiplication should bring it up to something usable. Yeah.
How can we make the radius do not exceed a certain number? For
So
example, when I bring my attractor point on top of the circle, it gets really big. I don't want to like get past the circle.
yeah, with our current definition, it's kind of a brute force. Like you just have to kind of keep an eye on it. If you want to control it with a little bit more fidelity, that's where you can take a look at the PNG definition that is up on Canvas. I'm not going to talk about it now because it's a little bit confusing, but there's these 3 components here: remap numbers, bounds, and construct domain. Construct domain lets you set a cap on like the upper radius limit, and then kind of like a minimum and maximum value. You can really control that range really tightly. Great question. Any other questions? Oh, no, definitely submit whatever stage works for you, whatever you think is interesting. Just as long as it has some sort of like attractor point relationship in it, you're good. Good question. Yeah. Yeah, you're welcome to include your definition on the side in your screenshot, but as long as you've got kind of a functional definition, you should be fine. We don't really need to see like your spaghetti, so just a screenshot of your drawing is good. You can bake it if you want to, but you're also welcome to just submit like a red ghosty grasshopper screenshot. Yeah. Yeah. Yeah, so we'll get into that next class, but that's starting to move into data management territory. So I might have mentioned really briefly that when you see these dashed wires, that means that the data is structured in what's called branches. So all of these numbers, you can see there's like a dark bar that shows up every once in a while. That means it's kind of putting it in a separate folder or like a separate chunk. That comes from very early on in our definition. You can see the dash line starts all the way back at the beginning from when we created a bunch of points. And if we look at what's coming out of points, again, I'll go into this in a lot more detail in next class. You can see that's where these kind of like darker bars here start to show up. These are just different folders for storing these points. And right now they're organized in columns. So it's keeping those columns of points separate. Flatten is an operation if we right-click on this points output. So if we right-click on points and hit this down arrow where it says flatten. So right-click on points, and hit the down arrow. All that does is it moves everything into the same folder. It gets rid of all of those separate branches of data, all of those dark bars, and now all of your points are on the same list. We'll talk about what that means next class, but for now, if you're playing around with these definitions, that's what flatten points output means. Just a screenshot's enough. I don't think we'll come back to this definition, so just a screenshot's good. Any other questions? Yeah. Yeah, so if you select multiple things, it should kind of cook multiple things at the same time. You just have to make sure that you're kind of floating off in space. If you try to right click and you're hovering over an object, it's just going to bake that one object. So if you're off in space and I hit bake, it should be cooking all of my other geometry, including those points. You can see now I've got all of those points. I've got my grid. All of that stuff is baked. Yeah, good question. Yeah.
Can you just go over with remap these stats by using?
I'm gonna touch on that next class, if that's okay. Yeah, I can talk on it now. It's not required at all for this little checkpoint. But I'll go into that if nobody has any other questions. Okay, so I'll chat a little bit about remap numbers, which is a component that shows up on the PNG definitions up on Canvas. So remap numbers is also under maths. Yikes. So maths, domain, and then remap numbers. This component is really great because it takes any list of numbers. So let's say we've got our distance values. Maybe they range from 0 at the lower end up to 100 at the higher end. And there's all of these kind of values at different places in between. We plug that list of numbers that we're starting with into value. It asks for a source domain. So it's basically asking, okay, what is the smallest number and what is the largest number? And then it asks what you wish those numbers were. So target is asking, okay, if you're starting with 0 to 100, maybe you want those numbers to actually fit between 0 and 10. This component kind of preserves those relationships. So if I had a point at like 30 maybe, so 30, if I run it through remap numbers and I tell it that the target domain is 0 to 10, that number that started as 30 is going to be turned into 3. So it's preserving those relationships, but it's letting you get a little bit more control than just using a divide component. So when we use divide, it's kind of like it's a pretty blunt instrument. We don't have a ton of control on what those outcoming numbers are unless you're really good at math, which I'm not. So instead, we can control exactly where those numbers start and where they stop. Just by telling it kind of what the initial extremes are and then what we wish those extremes were. So to get the initial values, we can come to this component remap numbers. I'll plug in all of my distance values. I'm gonna delete some of, maybe not. Okay, so we just need to come back to our distance component and plug distance into value on remap numbers. These are the numbers that we want to change. So distance goes into value. Source, this is asking what is the range of those numbers as it is. So what do those numbers, what's kind of like the smallest number and what's the largest number? It's asking for the extremes. And we can get that. We don't have to look at the list. We can just ask it using another component called bounds. So bounds is also under domain. So maths, domain, and then bounds. The icon is like a little number line and then the words min max. That's exactly what it's giving you. It's giving you the smallest number and the largest number in your list. So distance goes into numbers on bounds. You're feeding that list of distances into this component. And what comes out the other side, if you hover over it, for me it says 1 to 113. So the smallest number in this list is 1. The smallest distance is 1 unit. And the largest number, the biggest distance, the point that's the furthest away is 113.9 units away. So the smallest and the largest number. We can plug that into source. So domain goes into source. That's telling the component, okay, what are we starting with? Our starting condition. And then it's also asking, sorry, I'm just going to move this off to the side here. It's asking for a target. So if our starting point is 1 to 115, what do you want that range to actually be? In my case, maybe I want it to start at 5 and end at 25. And we can do that really quickly. We can tell it we want it to start at 5 and end at 25 using a panel. There's other ways to do this, but I'm just going to grab a little sticky note. So params, input, panel, and I can type in those numbers I want. So I'll type in 5 to 25. You got to type it kind of just like that. 5 space 2 space 25. It knows what that means. Don't hit enter. If you hit enter, it's going to wig out. If you hit enter, just hit backspace. Make sure you're all on one line. And click away. We can plug that into target. And then you can see what's coming out the other side is all of those numbers are remapped between the values of 5 and 25. So all of these numbers are existing somewhere between 5 and 25. If I change those numbers in that panel, so maybe I want it to start at 100 and end at 101. Oopsie. Yikes. You can see now those numbers are mapped from 100 to 101. They keep their relative value, but they're compressed or stretched to whatever I've specified under target. Does that make sense? That's a little bit more like next level data math stuff. We'll talk about it a little bit more next class. Any other questions? Yeah.
Really quickly, in the PNG for non-primary services, what is that, like,
Let me take a little look-see. Non-planar surfaces. Oh, this little component here?
yeah.
So this is another way of drawing a point inside of Grasshopper. So instead of having a point in Rhino and then referencing it into Grasshopper, another way we can create points inside of Grasshopper, kind of skipping Rhino altogether, is under the Params tab, Input, and then this little component called MD slider. The MD stands for multi-dimensional. So params, input, MD slider. And it's like a number slider that goes in two directions. So we can go from 0 to 1 in the X direction and 0 to 1 in the Y direction. And together, they can create point for us inside of Rhino space. So this one's probably really small, close to your origin. If you're not seeing it in Rhino, you might just have to plug it into a point container so you can select it. And then when you slide that little slider around, it's moving your point in Rhino space. Great question. You should be able to double click on it and make those numbers bigger if you want. So instead of going from 0 to 1, we can maybe change it from 0 to 100. 0 to 100. I'll hit OK. And now my point is floating out there in space. I can slide it around in Grasshopper. So that's the MD slider. Okay, any other questions? I'm going to stop there. We'll wrap things up. I'll stick around for a little while in case anyone wants to talk anything through. But otherwise, have a wonderful weekend. Don't forget to upload your screenshot to Canvas, and we'll try to get those checkpoints marked and back to you ASAP. But otherwise, you're free to go. Have a great weekend, y'all. Happy Friday. Ooh, ooh.